In this video, we're going to talk about polynomials, and then we're going to start getting to adding, subtracting, multiplying, and dividing. And we'll only look at addition and subtraction of polynomials in this video here. First, I want to start off with the definition of polynomials in a single variable. Single means single or one variable, all right? Basically, a polynomial of a single variable is a sum of terms of the form a times x to the n, where a is a real number and n is a whole number. All right, I have a couple of examples of polynomial functions here. First, we have 3x squared plus 2x plus 7. That is an example of a polynomial. Notice that an x to the n that I write here, there are actually three of them. One of them is 3x squared, the other one is 2x, and the other one is 7. Even though it doesn't have an x with it, it's still of the form a times x to the n. So when you don't see an x, that means that n is 0. All right, here n is 1 and here n is 2. Another example of a polynomial function, 3x to the 10th plus 4x to the 8th minus 3x squared plus 1. Notice it still has the same form here. Again, you have 1, 2, 3, 4 terms in that polynomial. And I have one last example, x squared. It's the only term in that polynomial. And notice I am using the word term. All of these things that are written in this form right here, like the 3x squared, the 2x, the 7, the 3x to the 10th, the 4x to the 8th, the negative 3x squared, the 1, and the x squared, those are called terms of the polynomials. All right. One definition that's going to be very important as we continue throughout mathematics is to be able to determine the degree of a term. The degree of a term is nothing more than the exponent on the variable of that term. For instance, if I look at 3x squared here, the exponent on the variable is 2. That means the degree of that term is 2. Let's look at some examples down here where I find the degree of each term. All right, in part A, I have a 3x squared, where my exponent here is 3, so the degree of this term would be 3. In part B, I have 5x. Notice here, there's a 1 understood to be as the exponent on the x. That way, we know that the degree of that term is 1. And last but not least, in part C, our term is a constant term. It's just a number which is constant. It doesn't have a variable, something that varies. And so remember, anytime we raise something to the 0 power, it equals 1. So I can really write this as 2x to the 0 power. And as you see that 0 on that x, you'll see that the degree of that term would be 0. All right? So that's the degree of a term. Some other definitions that I want you to know are definitions that we use to classify polynomials. There's 3 classifications. Monomials, notice the prefix mono here. That mono means 1. And so monomials are polynomials with 1 term. Here we have binomials. Bi is the prefix here. Bi means 2, so that's going to be a polynomial with 2 terms. And then last but not least, we have trinomials. Tri, prefix here, means 3, so it's going to be a polynomial with 3 terms. Polynomials with more than 3 terms, we'll just call them a polynomial with, let's say, 4 terms or 5 terms or so on and so forth. There's no special name that we will use. So what I want to do in these next examples is to classify each of these polynomials as a monomial, binomial, or trinomial, and then we're going to list the degree of each term. First example, x squared minus 9x plus 20, right? Well, it has 3 terms, so that means it is a trinomial. And now we're going to list the degree of each term. If I look at the x squared, the degree of that term is 2. Here, if I look at this minus 9x, notice that's a negative 9x because remember, a polynomial is a sum of terms. And so this is like adding a negative 9x, right? And so in either account, the degree will be the same as the exponent on that variable, which is 1. And then last but not least, remember there's always understood to be an x to the 0 power at the end there, so the degree of that term would be 0. Our next example is negative 92x to the 7th. And so here I only have 1 term, so this is going to be called a monomial. And the degree on that term is going to be the same as this exponent here, which is sitting here, which is 7. So that's the degree of a polynomial as well as classifying it. Some other important terms that we're going to be working with when we're dealing with polynomials are coefficients, and we'll start with that. That's the numerical part of each term, including its sign, right? And so I have this polynomial here, 4x cubed plus 3x squared plus 2x minus 1. All right, all of my coefficients include the following numbers. In front of my first term is 4, my next term, 3, my next term, 2, and my next term, since it's minus, I'm going to write a negative 1. These are all the coefficients. Those are the numbers that's involved in my polynomial. The next definition I want to look at is leading term. It's the term with the highest degree. All right, the actual term with the highest degree. Right? Remember, your degrees are your exponents, and so if you look, this is the term with the highest degree. So it's 4x cubed. All right. Our next example, or definition we want to know, is leading coefficient. All right, it's the coefficient of the leading term. Well, we just found out that this was our leading term since it had the highest exponent, and so the coefficient, or the number that's multiplied there, would be 4. So our leading coefficient would be 4. And not only do we have a degree of each term, but we also have a degree of the polynomial, which is the highest degree out of all of the terms. All right. And so if you look at the degree of all of these terms here, the term with the highest degree is your leading term, which we already figured out. And the degree of that in this case, or in this example, is 3. So our degree of our polynomial is 3. All right, and so let's look at another example where we do all of this. We're going to look at the polynomial function f of x equals x cubed minus 8x squared minus x plus 20. And in this example, we're going to determine the coefficient and degree of each term and the degree of the polynomial. All right, and so let's get started with that. Well, I have these 4 terms, x cubed, 8x squared, negative x, and 20, right? I'm going to write the coefficient for each of these terms next. The coefficient here is 1. We have an 8, a negative 1, and a 20. And now I'm going to write the degree of each of these terms, which is the leading not the leading coefficient, but the exponent on the variable, which is 3, 2, 1, and 0. So I have my coefficients. I'm going to abbreviate with COEFF. And then I have my degree of each term. Now what I want to do is write the degree of my polynomial, which is the same thing as the degree of my leading term, my highest degree. And the degree of my polynomial is 3. Notice how we wrote this polynomial. It had its highest degree first, followed by the next lowest degree, the next lowest degree, and then the lowest degree term. That's how we always end up writing our polynomials. It's just something that we get used to doing. All right, and so those are all the definitions that deal with polynomials of a single variable. What I want to do now is I want to be able to evaluate polynomials at certain values of x. All right. And remember, whenever we use the word evaluate, that just means to plug in or substitute the value in for the variable. So in this example, we're having x cubed plus 7x squared minus 6x plus 40. We're evaluating that for x equals negative 3. Remember, anytime you use a negative, or you can just get in the habit of always using parentheses when you raise something to a power. 7 times negative 3 squared. Excuse that right there. Minus 6 times negative 3 plus 40. All right, and the rest is just simplifying. You got to remember your rules of exponents, right? But I have a negative 3 raised to the third power, which is negative 27. Notice that this negative 3 squared here is the same thing as 9. And if I multiply 7 times a positive 9, I get a positive 63. That's a minus 6 times negative 3, which is a plus 18, and then plus 40. And when you combine all of those together, you're going to get 94. So that function evaluated, or that polynomial evaluated at x equals -3 equals 94. Now we want to get to adding and subtracting polynomials. We'll start with adding. We've actually already been adding polynomials before. We just didn't say that we were adding polynomials. It is as simple as combining like terms. Combining like terms. Remember, when you combine like terms, all you do is you add your coefficients together, and then you will have your terms combined. Or add or subtract your coefficients. All right, and so in this example, we have these two polynomials here, x cubed plus 2x squared minus 7x plus 4, and we're going to add to that the polynomial x cubed plus 6x squared minus 4x minus 13. All right, again, look at your terms that are the same here. For instance, I have an x cubed here and an x cubed there. When I add them together, I'm going to get 1 plus 1, which is 2x cubes. All right. I have 2x squared here and a 6x squared. When I add those together, I'm going to get plus 8x squared. Right? So we're adding these polynomials together. Next, we have a negative 7x. And I'm going to add that or combine it with a negative 4x. That's a negative 11x. So I can write that as minus 11x. And then last but not least, we have 4 and a negative 13. If I combine those, I get minus 9. So our polynomial here is 2x cubed plus 8x squared minus 11x minus 9. Let's get to subtraction. All right, when we first started talking about subtraction at the very beginning, when we dealt with integers, we said that when we subtract two integers, let's say we have 2 minus negative 3, what we can do is we can change the sign of that subtraction to addition, but if we do that, we have to do the opposite of that negative 3, which is a positive 3, and we will see that we get 5. The same thing works with when we subtract polynomials, right? And so what I'm going to do in this example that I have down here, 3x cubed plus 6x plus 6 minus, and notice that this polynomial is in parentheses because I am subtracting the entire polynomial, not just this first thing right here, but the entire polynomial from this entire polynomial here. And we can apply the same rule that we have up here. So let's do it. All right, so I'm going to take the 3x squared plus 6x plus 6, and I'm going to change my subtraction to addition, and I'm going to do the opposite. Negative 4x squared, and I got to do the opposite of every single thing inside of this parentheses here. So that's going to be a plus 9x minus 15. And now I can apply the same rules that I just used in the previous example where I just combined like terms, right? And so this is going to equal a negative x squared. And when I combine these two terms here, that's going to be a plus 15x. And then last but not least, I can combine these last two terms here, which is a minus 9. So I get a negative x squared plus 15x minus 9. In this example, I would like to find a missing polynomial, okay? 3x to the fourth minus 7x cubed plus 4x squared minus 2x plus 5. I'm subtracting that from this polynomial, some other polynomial, which I'm giving you as question mark. Just so I won't have to keep writing this question mark, I'm going to say f of x. Okay, so that's going to be like my variable that I need to solve for here, or I need to find. And I know that my result when I do the subtraction is x to the fourth plus 10x to the third minus 2x squared plus, that should be a 6x, and then minus 1. All right. Notice I have an unknown here. This is what I want to find. I want to find this missing polynomial. And just like when I solve regular equations, I'm going to apply those same techniques that I use to this example here. Right. Notice I want to isolate this f of x here, this minus f of x here, but this is on the same side with that. And so what I'm going to have to do here is I'm going to have to subtract this thing. And the reason why I know I have to subtract this thing is because that's the plus sign or a positive on the outside of that parentheses there. And if I ever want to get rid of a positive in an equation or get it to the other side, I have to subtract that thing from both sides. And so that's what I'm going to do here. I'm going to subtract this 3x to the fourth minus 7x cubed plus 4x squared minus 2x plus 5. I'm going to subtract it from both sides of this equation here. What we have to remember here is that our rules of cancellation still apply, right? When I subtract something from itself, I get 0, right? And so on my left-hand side, I am going to be left with negative f of x. And I'm going to write it over here so I can have enough room. And on my right-hand side, notice here, I'm taking this polynomial right here and subtracting from that top polynomial this polynomial right here. And we just got finished saying that when we subtract polynomials, it's going to be the exact same thing as adding the opposite. And so what I'm going to do is I'm going to add the opposite. So I'm going to have the x to the fourth plus 10x cubed minus 2x squared plus 6x minus 1, and I'm going to add the opposite of everything in this bottom parentheses, which is given right here. All right, so the opposite of a positive 3x to the fourth is a negative 3x to the fourth. I have a positive 7x cubed, a negative 4x squared, a positive 2x, and a minus 5. And now, I'll still have my negative f of x, which I want to isolate, but I got to simplify on my right-hand side of this equation. A positive x to the fourth plus a negative 3x to the fourth is a negative 2x to the fourth. I have a 10x cubed plus a 7x cubed, that's 17x cubed. I have a negative 2x squared and a negative 4x squared, that's a negative 6x squared. I have a 6x plus a 2x, which is an 8x, and a negative 1 minus 5, which is negative 6. And so this right-hand side is simplified, but you got to remember, we still have a negative out front here, right? And so if I want to get rid of a negative, that's like multiplying f of x by negative 1, then what I can go and do is divide both sides by negative 1. And I'll get that f of x equals, well, if I take a negative 2x to the fourth and divide it by negative 1, I get a positive 2x to the fourth. And so this basically means just change the signs here, because when I multiply or divide by a negative 1, it makes my signs opposite. And this is the polynomial that was missing in this set of in that question mark there. All right. The last thing I want to get to in this video is to look at polynomials of several variables. These are polynomials that may have 2, 3, 4, even 5 variables or more variables. We're only going to look at polynomials with at most 3 variables, but most often they're going to have 2 variables. And I want to look at just 2 definitions here. The degree of a term, that's the sum of the exponent in each term. And the degree of the polynomial is going to be the same as the degree of the polynomial with the highest degree term. All right. There we go. And if we look at this example here, it says find the degree of each term and the degree of the polynomial. Let's employ those definitions that we just talked about. Here, if I want to know the degree of that term, I add up the coefficients, which are not coefficients, the degrees are the exponents here. I have an 8 and a 6, and so the degree of that term is 14. Here, the degree of this one will be 3 plus 7, which is 10. And the degree of this term right here will be 11 plus 5, which is 16. And so if I want to know the degree of that polynomial, then my degree of my polynomial will be the highest degree out of all of these terms, which is 16. Okay. And last but not least in this video, we'll look at adding and subtracting. More specifically, we're going to look at one example where we add to polynomials. And so I have the polynomial 5x to the fourth y squared minus 6 times x cubed y to the third. And I'm going to add that to 8x to the fourth y squared plus 2x cubed y cubed. All right. And so this is just not given to you in our normal way of, giving you an addition. So I'm going to write it out here. So I'm going to take that polynomial there. That's a 2 here. And I'm going to add it to this polynomial here. Remember, we're just going to combine like terms just as we would before. But our terms have to have not only the same variable with the same exponent in case of one variable, but all variables must match up. All right. For instance, if I look at 5x to the fourth, y to the third, I've got to look in this set of parentheses here to find the term that has an x to the fourth y squared, and that's what I'm going to combine this with. And so if we look here, it's this term right here, and they combine to give you 13x to the fourth y squared. And then last but not least, when I look at this term right here, I got to make sure that if I'm going to combine it, it's got to combine with another x cubed y cubed, which I see here, as well as here in this polynomial there. And if I combine those two terms together, I have a -6 plus 2, which is a -4, and I keep my variable parts the same. And that concludes this video.